The system, we have a water skier. We'll represent by this dot. And we're told there's a number of forces acting on it. We have a force of Fg. And it's moving to the right with an acceleration, so we know the net force is not equal to 0. Horizontal tension, the force of tension exerted on the skier. There's a horizontal drag force, Fd. There's also a lift force acting on the skier. So if this skier is moving across the water, which I've kind of drawn in like so, well, we know the water skier is not accelerating vertically. So these two must be equal and opposite to each other. So if we take this lift force, let's say it's 10 newtons, then gravity should be minus 10 newtons. And, well, this might be a true statement. It should be equal to 0. 10 minus a minus 10 should be 0. So one of our choices is C right off the bat. And if the thing is accelerating, and we've drawn this to the right, if this is the correct direction, we can see that there is a net force in this direction, which would cause it to accelerate to the right. And so if we take the tension, subtract the force of drag, it shouldn't be 0 because it's accelerating. So that would take choice D out of the mix. And if we look at the first choice, the tension minus the drag force would be ma, producing the acceleration. Looks like that's the answer. Now, it's interesting, this choice here is an interesting one. L minus Fg does equal ma. It's just that the acceleration is 0. But we can see then that choices A and C are much stronger choices for us to land on.